Okay, so we are in lesson 6 for identifying number of solutions for linear systems of equations. We are going to find out that there's more than just one solution sometimes. So there are linear systems can have a solution or many solutions, and they are said to be consistent. So here we go. Number of solutions of a linear system. There are 3 possible outcomes. The first one has exactly one solution. So let me pull up my yellow highlighter. So it says here they have one solution. So they have exactly one solution. It is at one point. They intersect at one point, and the intersection of this is the solution to the system, and they are called intersecting lines. Makes sense. They intersect. So they're called intersecting lines. All right, let me pick up another color of highlighter. Let's go with orange this time. Now, there are ones that have many solutions. Those are called coincident lines. And think about the word coincidence if you know that. The word coincidence means, oh, it happened again. And that's kind of what happens here. If you look, there's just one line here, and you're thinking, well, I thought a system was more than one line. Well, what happens is these lines end up being on top of each other, and they end up being the exact same line. So lines that are coincidents overlap and have infinitely many solutions. Any ordered pair that is on the coinciding lines is a solution. So these are called coincident lines. I'm going to highlight that. Let me write it in. Coincident. So what a coincidence. It ends up being the exact same line. They're one on top of each other. Here, I forgot to work. Oh, that I didn't want to. Jeez. Okay, I wanted to outline this. Intersecting lines in yellow. Okay. Last but not least, and let's go green. So green is linear systems have no solutions, and they are parallel lines. So no solutions, you can see that these two lines are parallel. So they're parallel. That means they never intersect, and we refer to those as parallel lines. Now, we're going to do this 2 ways. The first way we're going to solve these is what we call graphically, or through a graph. And then our next lesson, we will show you what they look like algebraically. So with algebra, kind of showing you the difference between the two. So it says solve the system by graphing. Identify the number of solutions and then classify the system as parallel, intersecting, or coincident lines. So we already did some graphing, so this is kind of nice to review. So this one says that y equals 3x plus 5, and then y equals 3x minus 3. So I'm going to pick up 2 different markers. I'm going to label this A. Remember how we labeled. So we're going to start at 5, and the slope is 3. So up 1, 2, 3 over 1. Maybe I'll go down and put one more in there. 1, 2, 3, back 1. Now, I know you cannot see my ruler, but I am picking up a ruler. I highly recommend that you use a ruler so that you can get an exact point. And, of course, it's not the most accurate, so we got to be really careful. So now we're going to pick up B. And it says y equals 3x minus 3, so down to negative 3. And we're going to go same slope up 3, 1, 2, 3 over 1, up 1, 2, 3 over 1. You've got a couple of lines there. So now we're going to look here. And you can see those lines are parallel. So number of solutions, meaning how many times do they intersect? And they oops, I forgot to see an intersect. Intersect, how many times do they intersect? Number of solutions, 0. They don't ever intersect. There is what we refer to as no solution. And the type of system we have, these are parallel lines. Okay, so parallel lines. All right, so number 2, we have to graph this one. Now, you can see with 2, neither one of these are in slope-intercept form, so that's the first thing I need to do. Ugh, a little bit of work to do. So let me rewrite the equation. 2x minus y equals 1. I have to get y by itself, so I'm going to add 2x to the other side, add 2x to the other side. So that gives me negative y equals 2x plus 1, and you guys know how to do this. We already covered this lesson. So divide by, this is like a ghostly lattice 1. So divide by negative 1, divide by negative 1, divide by negative 1. So y is equal to negative 2x minus 1. So that's our first equation. So I'm going to label that A, and let me graph that. So we start at negative 1, and we go down to, oh, wait a second. Whoopsie. Mrs. Smith made a mistake. Whoopsie. If we go right here, this should be, to put it on the other side, should be a negative 2. To put it on the other side, it should be a negative 2. So this should be a negative 2. So now that makes this a positive 2. So let me get rid of that. Whoopsie. Hopefully you were yelling at me, saying, Mrs. Smith, you've got it wrong. All right, so let's go back. Negative 1. And now you're going to go up 2 over 1. Up 2 over 1, up 2 over 1, pick up your ruler, draw a line that intersects like so. And you know what I forgot over here too? Boy, this is what I do. Well, this is what I get for doing these on a Friday night when I'm extremely tired. This is A. Over here, I should have labeled this line A too. Don't forget your labels. Boy. All right, now number 2. Let's go ahead and solve this. So again, I got to manipulate this one. It's not in slope-intercept form, so I'm going to subtract 4x to the other side. So that gives me negative 2y equals negative 4x plus 2. Divide by negative 2, divide by negative 2, divide by negative 2. And y equals negative 4 divided by negative 2 would be 2x. 2 divided by negative 2 would be negative 1. And look at that. It's the same line. So now I'm going to pick up the green. I'm going to label this B, and I'm going to do the same thing. So I start at negative 1, and I go up 2 over 1, up 2 over 1, up 2 over 1. And again, I draw my line, and it's the same thing. So it's B. It's what they call overlap. They overlap. So how many solutions, or how many times do they intersect? And here's the thing. They intersect every single place on this line the whole entire time. So number of solutions, infinitely many. And of course, you could use that infinity sign if you wanted to. And the type of system, this is called coincident lines. Coincident lines. All right, last but not least, let's try these. They're already in slope-intercept form. Yay, yay. So let's graph. So we're going to start with 1, and it's up 1 over 2, up 1 over 2, up 1 over 2. That looks good. So I'm going to draw my line. Don't forget the label. Let's try not to forget this time. A. And then B, let me pick up my green, and it goes through at 8, and the slope is negative 3, so down 1, 2, 3 over 1, down 1, 2, 3 over 1. Ah, right there it is. So now I'm going to draw my line here like so. And number of solutions, so where is the point that they intersect, or how many times do they intersect? And S-E-C-T. They intersect just one time. So number of solutions, 1. And the type of system you have, these are called intersecting lines. So just kind of adding on to what you already know. Now, we're going to go down and we're going to kind of put together some conclusions or some hints. Parallel lines will always have 0 solutions. They'll have none. Okay. Coincident lines will always have infinitely many solutions. Okay, or you could do the infinity sign. Intersecting lines will always have 1 solution. Okay, now I want to go back up and I want to do some comparisons. And I want to kind of look at these two different things, the slope and the y-intercept. Let's go ahead and pick up, let's pick up a pink. And I want you to look at the slopes here. I have a slope of 3 and I have a slope of 3. So what do you notice about these slopes? I think you're going to see that you have the same slope. So that's going to be important to kind of pick out. The slope is exactly the same. Now I want you to look at, let's do a baby blue. Let's look at here, the y-intercepts. Whoops, I don't want that. So the y-intercept is right here. So 1 is 5 and 1 is -3. So you should see that they have different E-R-E-N-T. Whew. I got to stop doing videos tonight. I'm struggling. I'm tired. Different y-intercepts. So that's going to be important that you recognize that. So for the equation, they have same slope, and I'm going to write it down here kind of in my little cheat sheet box, my little table here, and they have different y-intercepts. Okay, so now let's go back up to this next one. If we look at, let's do pretty in pink again, we look at the slopes. What do you notice about this slope and this slope? They have exactly the same slope. So same slope again. And then let's look at the y-intercept. So the y-intercept, I have a -1 and I have a -1. So here they have the exact same y-intercept. So that's going to be important, especially when we start to do these algebraically. So they have the same slope and they have the same y-intercept. Now I want to talk about one more thing. It's kind of like these two lines are identical. The two lines are identical. And of course, remember, identical, infinitely many solutions, they both start with I. And I kind of gave you that hint back a couple of chapters ago when we were talking about number of solutions. All right, last but not least, let's go ahead and go back to look at our slopes again. So look at this slope. This is 1/2 and this is -3. So when you have one solution, they are going to have different slopes. And then the y-intercepts for that really do not matter. So they could be the same, they could be different. It doesn't matter. Once you see different slopes, you automatically know it's going to be one solution. Okay? So the y-intercept does not matter. So they could be the same, they could be different. It doesn't matter. As long as you see different slopes, you are going to know one solution immediately. Okay? So you can go on, we will go on to solving a system, or you could go on, practicing this, but I'm going to stop the video here because you kind of have what you need to be able to solve. All right, have a good one.